For nearly 50 years after its invention, the humble food can remain almost impossible to open easily. Imagine needing a hammer and chisel just to access your dinner, a daily challenge for countless households. The seemingly simple can opener represents a pinnacle of clever mechanical design, evolving over centuries. Before its widespread adoption, people opened metal cans using bayonets, hammers, or even sharp rocks. This daily struggle highlights a common human problem. How do we interact with rigid containers? Early cans, initially designed for military provisions, featured extremely thick steel walls, complicating access significantly. Accessing preserved food was a tedious, often dangerous task, frequently resulting in painful injuries. This widespread frustration spurred ingenious inventors to seek more elegant and practical solutions for everyday life. Eventually, engineers focused on creating a device that could slice metal safely and efficiently. They needed a tool harnessing fundamental physics to overcome the can's formidable barrier. Understanding its operation reveals core principles of simple machines working together harmoniously. This everyday kitchen tool beautifully demonstrates the power of leverage and rotational force. It allows millions to effortlessly enjoy food sealed perfectly for long-term preservation. Modern can openers typically employ two main components, a cutting wheel and a driven wheel. You first firmly align the device's sharp cutting wheel directly against the can's rim. Simultaneously, the driven wheel grips the outside edge of the can's lid. Turning the handle engages a worm gear, a helical screw that meshes with another gear. This action rotates the driven wheel, which then systematically pulls the entire can forward. Imagine tiny teeth on the driven wheel biting into the can's curled edge, providing traction. The cutting wheel, a simple wedge, then presses down with immense localized pressure.
But how does one small blade slice through tough metal so cleanly?
The cutting wheel's beveled edge concentrates all the applied force onto a very thin line. This creates an incredibly high pressure point, easily exceeding the can's metal yield strength. As the can rotates, the cutting wheel continuously slices through the lid's top surface. It doesn't tear the metal. Rather, it performs a precise, almost surgical separation. The two wheels work in tandem, while the other applies the shearing force for cutting. One wheel anchors the can, while the other applies the shearing force for cutting. Yet, there's a crucial design element, preventing metal fragments from falling inside. The cutting wheel doesn't just cut. It also slightly curls the severed metal edge outwards. This ingenious design ensures the detached lid remains connected to the can via a small hinge. You can then lift the lid safely and cleanly without it dropping into your food. Some advanced can openers cut along the side of the can, just below the rim. These designs use a different mechanism, separating the lid from the side seam entirely. They create a smooth, resealable edge, eliminating any sharp or jagged hazards. But what if the can's material itself presents an unusual challenge? The fundamental principle, however, remains consistent. Apply focused force to sever the metal. The worm gear mechanism provides a significant mechanical advantage, multiplying your hand's power. Even a child can easily operate a well-designed can opener due to this leverage. It transforms a small twist into enough rotational and cutting force for opening. This intricate dance of gears and blades perfectly illustrates basic engineering principles. Understanding these simple machines unlocks the secrets behind countless everyday tools. Each component plays a vital role, ensuring a seamless and efficient operation every time. The can opener dramatically changed daily life, making preserved food truly accessible for everyone. It democratized nutrition, allowing families to store and consume goods previously unavailable. No longer did people require specialized skills or dangerous tools to access their meals. This simple invention significantly improved kitchen safety, reducing countless cuts and injuries. It contributed directly to better public health outcomes by making nutritious food easier to obtain. The can opener's widespread adoption also fueled the growth of the canning industry globally. Factories could produce canned goods knowing consumers could open them conveniently at home. This seemingly minor mechanical breakthrough had massive implications for food distribution systems. It enabled explorers and soldiers to carry portable, long-lasting provisions more safely.
Imagine expeditions without this reliable tool. Sustenance would have been far more precarious. The can opener exemplifies how small mechanical innovations create profound societal shifts.
It proves that elegant design can solve complex problems with surprising simplicity and efficiency. Next time you reach for a can, appreciate the engineering marvel in your hand. This unassuming device connects us directly to centuries of inventive problem solving. It is a testament to human ingenuity, transforming a struggle into effortless convenience. Ultimately, the can opener stands as a powerful reminder of how elegant engineering simplifies our daily world. Its ingenious mechanism transforms a formidable barrier into a trivial, effortless task for millions every day. If you found this fascinating, subscribe for more incredible stories and share your thoughts below.